Hi, this is Dilip and Raghu. This is regarding the Data 620 Web Analytics Project 1. For this project, we selected the Bitcoin dataset. This dataset contains the Who Trust Whom network, wherein the users go about rating each other's based on various factors like trust, and other factors, and they give us the rating for each and every user in a scale of -10 to 10, with -10 being the person with not that much trusted, to 10 being a person who is like more trusted in the network. And we all know Bitcoin is an anonymous um, anonymous transaction kind of an platform. So trust is an important factor, or the users who has the more trust um, helps us to identify, yeah, these are kind of good individuals who are sitting in the network. For the project, we went ahead and took the data set from our Snap database. Uh, uh, there were many Bitcoin related data set, and we took this particular one. For the project, we said we will analyze the data set, and since the rating was there in the data set, we thought we will use the rating as a categorical variable, wherein we will split them into both positive values and negative values, and then go about doing the analysis. The next set is loading the data set. So moving to the program, loading the package. Okay, so we had the set of packages that were necessary for us. Then we went about reading it. We had the file stored in the GitHub repository, and from there on we read the file. Once we read the file, the next thing that we did was removing the timestamp. There was a timestamp component to it, and we went about removing it because it was not needed for our analysis. Then looked into the data set, and we wanted to see how the head and tail of the data frame that we have loaded looks like. So we can see there is the source, there is a target, and the corresponding variable. This is the source user, this is the target user who did the rating, and then the what rating it was given. So that was basically the head and tail, and then we went about describing the entire data frame just to see what was the median across each and every variable, followed by the standard deviation across the variables, and then minimum quartiles, and then the max. Okay, next moving to the data set, having the data set loaded, we went into the analysis piece and we wanted to see how many edges are there in the network. And then we saw the number of edges, and then we wanted to see how many nodes are there in the network. Okay, that was 10. So we had these many number of nodes. Next, what we did was, as we said, we wanted to assign we want to use the rating as a categorical variable. So we split the data based on both positive as well as negative ratings. And then we wanted to draw the network, and we went for a spring layout. After again, just like previous exercise, we tried many other layouts, and then we settled on the spring layout because that was more readable. And then what we did was we draw the edges of both the networks. For the negative, we gave a color scheme down the analysis. You can see the color scheme, and then we wanted to have it dashed out compared to that of the straight lines that the positive network is going to have. Based on that, we did this drawing. I'm not going to run this particular piece of code because it takes a lot of time. Having said that, as per the question, we wanted to analyze the degree centralities and all the components related to space centrality and the eigen vectors. So we went ahead starting going inside the degree centrality. Degree centrality has the definition says is defined as the number of links incident upon a node, or in other ways like how many edges or how many connections that a particular node has. So that is the degree centrality of a node in a network. So having said that, we the first thing is we figured out like what are the maximum number of connections that a node has. So there is some node in the network or some user in the network, because we are talking about the user data, who has 511 connections, and there is a person or node in the network which has just only one connection. That was this centrality measure means. And then isolates, we just wanted to check, like, is there anybody who is not at all connected to anybody? But no, it's not like that. Once that is done, we wanted to list out the top 10 degrees individuals who has the highest degree centrality. So we went about running that code, and then we saw the user one. He has the maximum number of connections in the network. So we could now say, like, it's an influential person, but it's too early to judge unless until we know the eigenvector. We can't say he's the influential person, but we can say that he has many connections in the network. So these are some of our individuals who have maximum number of connections: 8, user 3, user 2, user 11, user 7. So there are quite a number of individuals who have pretty good connections in the network. Okay, next is the closeness. Okay, closeness. Uh, this is another important concept in the centrality measures. As the definition says, like, which is the shortest path. Like, if two individuals are connected, what it does is it measures scores for each and every node based on the closeness to all other nodes within the network. So in other words, it just does the calculation of the shortest path between all the nodes, and then it assigns a score, and this is that score, and then it ranks the individuals based on that score. So with respect to closeness, like, who is more closely knitted, the user 2 is closely knitted. That's the statement that we are giving here. The closeness points that appears in centrality are 2, 11, 5, 1, 4, and 15. And if we compare with that of the degree centrality, these individuals are there also. For example, in top 10 in degree centrality. So there is 2, there is 11, and then there is 4, and there is 4, yeah, there is 4, and there is 1, of course, 1 is there, and then there is the user 15. So all these individuals are more or less there in terms of the centrality as well as on the closeness. Okay, since I have clicked this is running. So just hold on for a few minutes. I think it should be done. It should get over, and I hope you can see the speed in which my you can hear the sound of my RAM spinning behind. I think it's taking a lot of computation. I don't know why, but just hold on to it. Oh yeah, it's done. Good. Thankfully, I'm not going to click on the rest of it because I don't want to burn my processor, so I'm just going to keep describing things. Next is the betweenness. Next, what we have done is we did the betweenness. We did the ranking of the betweenness. Betweenness as the concept of it is also a centrality measure. It says a number of this is nothing but the number of times a node sits between the shortest path between the two other nodes. So what it actually says is uh, a high betweenness count could indicate someone who has more control over the network or who has more authority over the network. Rather than saying it as a network, we could say it as a cluster. So that's the betweenness score, and then we did the betweenness analysis, and then the last thing that we did as per the question was a calculation of the eigenvector values. And based on the calculation of eigenvector values, what we see is user number 11. He is the most influential person in the network. We could say that he is more influential. And then one who has more number of connections in the network, who had 511 connections in the network, still makes to the top 10, but he is not even in the top 5. So that's even he is one of the influential person, but not like 11. So That's the thing that we are saying, that the high degree centrality like 4, 15, and 5 does not appear in the high degree eigenvector list. So these are few things that were there in the centrality network which are not even there in the eigenvector. But in other ways around, conversely, high degree of eigenvectors like 26, 95, and 24 does not even appear in high degree centrality. So we can say that pretty much we can say that a person who has a large number of connections doesn't need to be the most powerful person in the network. So that's the conclusion that or the understanding that we came from these codes. Okay, moving along. Then we wanted to categorize the network, as we said, based on the ratings. One is the highly positive network in terms of trust, and then highly negative network. So that's the next step that we wanted to do, subnetworks by trust. Based on that, instead of going, what we have done is positive networks are those folks which has a rating greater than 5. Instead of greater than 0, we just went with greater than 5. And then we drew this. We wanted to list out the number of edges in the positive network and what is the degree centrality in the positive network. And if you see, the number of nodes in the network is 725. So the positive network, or not, I won't say positive network with a rating greater than 5. So it is 725 nodes all there in the network, out of how many nodes? If I remember, that is the total nodes in the network that we did. What? Yeah, out of 3,783, only 700 and my bad, sorry for scrolling. Yeah, only 725 nodes in the network or having a positive rating greater than 5. So that's what, and then we went about seeing like out of those individuals in the positive network or positive cluster, who has the high degree centrality. The user number 2 has high degree centrality. He has 53 connections, and then he has the high eigenvector. So probably he's the most influential person also in the positive cluster. So the next thing that we are doing is only 6% of the network has rating more than 5. It is interesting to note that 629, 7604 are not part of the list of the top 10 list of the degree centrality of the entire network. And on the other hand, only 2 is appearing in the top 10 list of eigenvector. So what we tried to do an analysis between the positive cluster with that of the whole network. And then we have plotted our observations. Okay, then we wanted to split the data for only 2 individuals. We wanted to see how individual 2, who was there in the eigen list, along with that of 6, who was not there anywhere. So that's the analysis that we have done here, and you can see from this that both the user 2 is has a high degree of centrality in terms of number of connections that he has, as well as the closeness that that particular individual has compared to that of 6. The next thing that we did was now we wanted to do the negative network classification, and then we repeated the same experiment again. Instead of going less than 0, we went less than -5, and then we did the number of edges and nodes. Those are there in the network, and then we did the we did the degree as well as degree centrality and the eigenvector calculation. And then we saw the user 7604 was 67 connections in the network. And then here we wanted to explore one individual 7596 who was in the bottom of the network. So we went out and seeing how many connections the particular individual has. Finally, what we have done is we went about writing. We went about seeing how the user 177 who has, where is the user 177 who has many connections, many degrees in the network. We wanted to see how he looks like. and this is the plotting for him. And our final conclusion is this: the overall, based on the clusters that we have decided, that we have separated, uh, uh, there were more negative ratings compared to that of the positive ratings in terms of trust factor. Uh, this is based on the cluster analysis that we separated out, and then we have provided. So that's our project one entire analysis that we have done. Uh, hope it lives up to your standard. Uh, that's it. Thank you.